Okay, enough for the warm-ups. Let's get started on the actual problems. First function we have here, what's the degree? Going to be using a lot of the tools that you used in the last lesson. Now the degree is not 2. If this were written in separate terms, all multiplied out, then the term with the highest exponent would be it. But these are still factors. So technically this has a degree of 1 and this has a degree of 2. It should come out to a degree of 3. Or we could write it in fully factored form. And then maybe be more obvious to us, because if we multiplied this out, x times x times x, our highest power would indeed be a 3. How many roots should it have? It should have 3 roots. Now some of them might be imaginary, but it should have 3 roots. Well, if it's third degree, then it's a cubic, and these factors are all positive, so it's a positive cubic. So it may look something like this. Y-intercept is not the number on the end, because this isn't multiplied out. If we multiplied it out, it would be the number on the end, but we're not going to. Instead, we're just going to know that the y-intercept is when x is 0. So y equals 0 minus 1 times the square on 0 minus 3. So that would be negative 1 times the square on negative 3, which comes out to be negative 9. So when x is 0, y is negative 9. And we already know 1 point on our graph. X-intercepts happen when y is 0. So we'd have that x minus 1, and I'm going to use the factored form here. That has to multiply out to 0. And the only way that can happen is if one of these factors equals 0. Whoops. So that would mean that x equals 1 or x equals 3 or this other x equals 3. Well, you can see that we have a double root. And we could have told that from the original with the squared here. And that means that the graph is going to bounce at x equals 3. We're going to have a tangent to the x-axis. So this is going to be a little tight here. So at x equals 3, the graph is not going to cross. It's going to bounce. And at x equals 1, the graph is going to cross through. That's just a single root. And it's got to look something like that. Well, so it's going to come up. It's got to go through the 1. It's got to go through the y-intercept down here. Sort of shaped like this. And then it's going to turn around and bounce off of the 3. So where it turns around here, we don't know. I'm just guessing. In calculus, we do find out where those turning points are. And that would be our positive cubic with a double root at x equals 3, a single root at x equals 1, and a y-intercept down there at negative 9. Okay, next one. Same story. The degree. Now we can look at this. This factor has a degree of 3. This factor has a degree of 1. So it should come out to a degree of 4. Or we could actually write all the factors, fully factor this. I made this one too soon. Sorry, that's supposed to be a 1. And you can see that x times x times x times x would make this a degree of 4. So there should be 4 roots. They might be imaginary. There may be some double roots. Basic shape. Well, this would multiply out to a quartic, and each factor is positive. So it may look something like a W. Sometimes the W is a little lopsided, but it should be a positive quartic. Y-intercept. I'm going to use the original equation here. That means we're going to put a 0 in for all the x's. Well, negative 1 cubed comes out to be negative 1, and we're going to be multiplying that times a negative 3. So that would tell us that the y-intercept is 3. When x is 0, y is 3. So we got a y-intercept. X-intercepts. Well, they're when y equals 0. So we'd have, and I'm going to leave it factored this time and try to copy it right. This is supposed to multiply out to 0. Well, that can only happen when x equals 1, or x equals 1, or this x equals 1, or this x equals 3. And as you can see, we have a triple root, a root with a multiplicity of 3. And that tells us that the graph is going to flatten and cross at x equals 1. So at x equals 1, it's going to do this flattening and crossing, and at x equals 3, it's just going to cross through. And it's supposed to kind of look like a W. So it's got to come down out of positive infinity. It's going to flatten and cross here. And then it's going to have to turn around, come back up, go out through the 3. So it's going to flatten and cross. It's sort of like a W. And we do indeed have 4 roots. There are 3 roots right here at x equals 1, and then the 4th root over here when x equals 3. Got one more. The degree on this one, we can just add these. Or we could list all the factors out. That this would be x times x times x times the quantity x plus 5 times the quantity x plus 5. And if we multiplied everything out, the x times x times x times x times another x would be x to the 5th. So this is 5th degree. The number of roots should be the same. These are all positive. So this is a basic quintic graph, which kind of looks like the cubic graph, but it can have an extra wiggle in it. Now this wiggle might go way down. It's going to have 4 turning points. 1, 2, 3, 4 places that it turns. Y-intercept, that's when x is 0. So just substituting a 0 in everywhere there's an x. Well, that's going to be 0 times 25, which is 0. So when x is 0, y is 0. You know the graph's going to go through the origin. The x-intercepts. That's when these factors all multiply out to 0. That can only happen if this x is 0, or this next x is 0, or the third x is 0, or this equals -5, or this x equals -5. So we've got a triple root here. And we have a double root over here. So this crazy thing is going to flatten and cross at x equals 0. It's going to bounce at x equals -5. Oh boy. And it's going to kind of look like this. So at -5, it's going to bounce off of the x-axis. It's going to come up from -infinity, bounce off of here, turn around, and then it's got to come up through 0, and there it's going to flatten and cross. I'm not sure it's going to look exactly like that. So we have 3 roots here, 2 roots here. We do have our 5 roots. It's a wild-looking equation. Sorry, it's a wild-looking graph. But they're kind of neat. And it'd be time now for you to try a couple.